Good afternoon and welcome to today's EMSL Learn webinar, where we will be discussing using Open OnDemand to remote access EMSL's computing resources. In July, you'll notice we don't have an EMSL Learn webinar scheduled because we're hoping that you will attend our EMSL Summer School, which is July 24th to the 28th. We will be discussing data analysis and visualization tools for omics. The link to register will be posted in the chat. So we hope to see you there. It's free and virtual. Also, we'd like you to keep in touch with EMSL. You have an opportunity to follow us by subscribing to our newsletter, so you always hear about the latest news and proposal call opportunities. In addition, we are on social media on Facebook, LinkedIn, Twitter, and Instagram, and we invite you to follow us. Now, today we have two speakers. We're joined by Felix, who is an EMSL IT engineer, and Maruti Mudunuru, a PNNL Earth scientist. With that, we are going to start with Evan. Thanks for joining us.
Hi, I'm Evan Felix. I work over in EMSL, and I help run the Tahoma supercomputer here in EMSL. And I'll talk a little bit about Tahoma, and then I'll show you the Open OnDemand tool that I've helped deploy and support. And I'll run you through a lot of demos of it as well. So as we get to that point, I'll switch over to a web browser and show you how to use that. All right, Tahoma is our primary high-performance supercomputer. It consists of 184 Cascade Lake nodes, each with 36 cores, 3.1 gigahertz with 384 gigabytes of memory in them. 164 of those are compute nodes, and then 24 of those are what we call ML and AI nodes with 2 Tesla V100s in them with 1.5 terabytes of memory. So that gives us an aggregate of 98 terabytes of memory with 10 petabytes of global storage in a BGFS file system and 536 terabytes of local disk with a peak performance of just over a petaflop. Here's a picture of one of the compute nodes. These are simulation and modeling nodes and have a little bit of flash storage in each one of them for local storage. Then those are the analysis machines. So each of those have a large bit of memory, and then those GPU nodes. And they have a lot of flash storage in them. So another 7 terabytes, which is larger than the compute nodes. So if you haven't used Tahoma yet, that's what's on there. So Open OnDemand, we run on this. It's an interactive, web-based way of connecting to Tahoma. Historically on our clusters, you've had to log in over SSH, which is command line based. This is a web-based connection to that. And all those applications, those web-based or desktop-based things run as the logged in user. This is a software come out of Ohio State University, and they all run as the log. And we've deployed some file system management, Slurm job control, command line, which is also available on there, a desktop environment, Jupyter Lab or Jupyter Notebook, Visual Studio Code, RStudio, and also our EMSL Nexus uploader. And I'll be demoing a lot of those things here today. Here's some links to get access to the Tahoma system. And we're going to connect to this URL here in the middle, tahomaondemand.emsl.pnnl.gov. When you go there, you can get to it outside the network as well as inside the network. When you're inside, you only need your username and password. And you might not even get authenticated if you've already authenticated through the single sign-on within the network. If you're outside, you'll probably be asked for your username and secure ID as normal if you're outside the network. Or if you're on the VPN, you'll probably just get the username and password. All right, at that point, we're going to switch over to demos. So there we go. Now I can share my screen. Well, that gives me all my windows too, doesn't it? Loading meeting. Okay. So when you first go to On Demand, you should get this screen here. And it gives you a little bit of status of the cluster, kind of how much it's used right now, what projects are currently using it, how much nodes are in use, and kind of what status it is right now. So first we'll go over the files menu up here. You'll see here that it'll kind of point you towards your home directory. If you have projects, it'll give you links directly into your Tahoma projects directory and possibly into your archive directory. We're going to jump into the one of my project directories. And you'll see it gives us that same list over here on the left side. And after a moment, it'll populate the directories I have under that project directory. And I'll show you some things you can do here. So you have your basic tools where we can rename, we can download this whole directory, we can download files. We can copy this file. Right? If you click on this copy move button up here, we're allowed now to copy or move it somewhere else. So if we change into another directory, it takes a second sometimes, so I always question whether I've clicked it or not. There we go. And you push the copy button to push it into that directory. Or you could push the move button, right? And you can see it's given us a status that it's copying the files. It shows that it's pushed those files in here. And then you can go in here and you can do things like if we want to download that file, we can do that. You can see it downloaded it for me. I can also upload a file if I want to do that. There's the PowerPoint we're currently watching. So we can push that into this test directory as well. We'll see some editing of files later. It has a simple text editor we can use, and we'll use that when we talk about jobs, so we won't do that now. We can move files around the file system, such like that. So let's actually talk about jobs right now. We can look at our active jobs on the cluster in this job section. Currently, I have my jobs. You can also see all the jobs on the cluster, and I'll switch over to that for now. It does take a few minutes to populate this. Not a few minutes, but a few seconds, I guess. You can see it loading up there. So I'll give that a moment. It just says no data while it's doing this. There's all the current jobs running on the cluster. But normally you probably care about your jobs. So I usually switch to that pretty quickly. I don't know if it'll show any jobs for me right now, but we will make one and then we'll be able to see one. So if you want to create your own jobs, you can do that in what's called the job composer. And these are jobs that I've run recently. You can see it's already created a simple hello world job for me that I haven't ever submitted based off the last thing I did. It just kind of makes one for me in case I want to do that. And this is where it's going to put it if I make it. I can base it off a template, which is what it did for me. kind of as the default, and you can build your own templates in case you're making the same jobs over and over again, the similar thing. And that's what I've done in this case. I've made this template called a simple hello world job. You can see it's got it in this directory, so I can go edit this directory and build up a set of things, a simple, an input deck, whatever I need to do. And then when I want to edit it again, I just say I want to create a new job based off that. You can see that, and I say, well, I need to modify this slightly. Press the open in the editor button. And after a moment, it'll load that in here. So for this job, we'll add short sleep, just so we can see it in the job editor. Save this file. For a second, it'll show up here that we did that. And then we'll just push this submit button over here. You'll see it's been queued now. If we go back over here, should show up in here after a moment. Might have to hit the reload. Says it's running now, but it's not here yet. There it is. Once it's running here, we can hit this little chevron and it'll give us some more information about the job. Where its outlook location is. If you hit this open in file manager button, it'll show it in that file manager directly. So you can see output after a moment. There it is. So if you click on that output file, you can see the output of our simple job that we made. All right. So we can manage our jobs, we can manage our files now. And you might have noticed there's buttons that we've passed a few times that say open in terminal. So all these things, when you hit open in terminal in these places, it should open a new tab. There it goes. Directly in that directory so that we can see those files directly, just like as if we'd SSH'd in as well. So we can see the job, we can see the output file, and we can actually edit the job if we wanted to. Right, well, maybe that sleep wasn't long enough. Right. And we can do our normal, just resubmit it. And now we've got a new job submitted. And after a moment, it should run it through Slurm again, and a new job should show up. And my hide meeting controls. Should output a new job here in a moment. We can also get those same terminals with this clusters window here. If you just click that, you'll get a terminal just in your home directory. And you can see all the files in my directory just as normal. And that'll be on a login node. All of these will show up on a login node, just like as if you'd logged in from Tahoma. So you can get terminals just like you would over the web. So you don't have to do any SSH in directly. You can load these directly into your web browser. All right, so let's talk about interactive apps. So that's going to be this next window over here. We have a bunch in here. Let's talk about desktops. A lot of people need to be able to have those interactive applications in a desktop. And so we provided some desktops on here. There's two different types we provide. They're fairly simple, basic Linux desktops. There's the Mate style or the XFCE style. Put them in there. you select which project you want to run it under. We'll run these under MSCOD, which is a project I have for on-demand stuff and some of my other projects. You'll notice I have one that has no hours left, so it just shows nothing there. And then you can select which partition you want to run it in. You can put it on the normal compute nodes or on the GPU nodes. When you run it on these, you get full access to the whole node and all the GPUs on it. If you select the workflow nodes, you get one CPU on a workflow nodes, and you're going to share it with other users. But if you just need a small desktop just to, be on there to, look at some output files or something, that works fairly well. So you can make that selection here. You select how many nodes you want, how many hours you want this desktop sitting there. And then you push the launch button. Give it a minute. You should see this little card show up. It says, I'm getting a node with 36 cores and it's going to be starting. This is actually giving it to Slurm to give it time to schedule it somewhere. If there's no nodes available, obviously Slurm may take some time getting you a full node. Hopefully this will give it to us in a quick amount of time during the demo. There we go. I'll show you a few things here. Shows us what host we got. There's a launch cluster desktop, which we'll push here in a minute. Over here, there's a link that says view only. You can right click on this and get the link, copy the link, and you can send this to someone else with access to Tahoma, and they can see what you're doing on the desktop, but not interact with the desktop. So if you're working with a coworker or a collaborator of some sort, you can send that to them and talk them through what you're doing without having to necessarily, bring up a full, Teams meeting or whatever you need to do. So this is a full desktop. We can run some graphics tools. Here's GNU or the GIMP. If you want to do graphics tools, there's a web browser here. If you want to run Firefox, you need to download things. We have got the Spider IDE. Someone requested that on here. You just want to run a terminal in here, you can do that. I know Spider's been reporting this error when I tested this morning. I haven't used Chimera. It's a thing in here someone else asked for, so we've installed that on here for people. So did our this so it's our full desktop experience, I guess. If you resize this, your browser, the desktop resizes with it, so that can be pretty useful as well. When if you're done with it, you go back to the on demand and you say I'm done, and you click delete, and it'll destroy the Slurm job. It'll tell Slurm destroy the job, and it will terminate the desktop and make this go away. I think it will. I think I clicked the button. So there's other, the Jupyter notebook and lab are a web-based app, so you don't need that full desktop. You actually just want it to show up in a web browser. So you have some similar options. You select your Slurm account. You decide where you want it, whether you need a GPU or whether you want that one process on a workflow node. And if you like the Jupyter Lab interface, or if you like the notebook only interface, you select that. Push the launch button. Wait a few seconds, and you should get that card that it's activating. when you click the connect to Jupyter, you see the logo, and you can see my test notebook that is, highly technical. But if we restart the kernel and run all the cells, it is really does some really complicated math for us. So I won't go too much into running this. I actually have a TensorFlow beginner notebook over here because Maruti later will show us all kinds of stuff with Jupyter Notebook, and he understands that stuff way better than me. So just wanted to show you how to start that and run that. And you can do terminals in here as well that people really like. So while you're doing your notebook, you can get access to the terminals as well. You can see my home directory again. So we have an RStudio server as well. So similar options, press the launch button. Wait a few moments while it sets things up. Start closing tabs here. Hold on. There it is. When you're done with these things, it's usually a good idea to close them, mostly to free up resources, because it's using your Slurm allocations, I guess. It's the best reason. RStudio server. I like to do in here is I say demo image and some demos of the Magna Wahoo volcano. So you use RStudio. So the last thing I want to show you on here is if you like Visual Studio Code as an editor on your desktop, you can also run that directly on the cluster. Now this one, there's not a lot of options for you. It runs directly on the login node, so you don't need a Slurm allocation. You just tell it how many hours you want it running, and it will run it for that many hours for you. And then it will kill it. Connect to it. The reason I like this is because it gives you a little bit more powerful editor than what you get with standard Open OnDemand in the file section. So let's scroll down through my files. Something more interesting. So then you can just start opening your files and editing them. And it does color coding and stuff. And as you edit them, it directly saves them on the cluster for you. And you can install various things. You do searching and editing and stuff like that. So, okay, we will stop sharing now. And Ollie, can you give us the slides back? Here we go. All right, so there's links here to our user guide for Tahoma. And there's a link there to a bunch of on-demand help that we've documented up. And if you have questions or have actual specific support requests, definitely email mscconsulting@emsl.pnl.gov. And I'm told pnnl.gov is the proper thing. I think both emails work, but go ahead and send to the pnnl.gov. It's probably the best one. And I'm told to have you wait till the end for questions, and I'll be happy to answer them. Looks like there's some chat that's been happening while I've been talking. But thank you for your time, and we'll pass it on to Maruti now.
Hello, everyone. Hope you can hear me. So building on what Ivan said, so today we'll be talking about how to use JupyterHub for various advanced analysis and open on-demand tools for the models that you're trying to develop and the EMSL data for model data integration. So I'm Maruti, I'm a staff scientist at PNNL. So I work with EMSL on various projects related to model data integration. So for the next 15 minutes, we'll be talking about JupyterHub and how to use the JupyterHub and various other resources on Tahoma for use cases, focusing on modeling using PFLOTRAN, model experiment data integration, and other advanced capabilities. So bring your own models, how to do data analysis, and how to integrate your models with the data, and other advanced AI model training on HPC resources such as Tahoma. So, what is this JupyterHub? As Ivan pointed out, it's a very popular notebook tool that is popular among the users to analyze data and also create some workflows for model data integration. So if you know Google Colab notebooks, it is very similar to the Google Colab notebooks. So you can request a node and have the set of analysis run based on the Python environments you have. So it's an interactive environment for scripting, visualization, and data analytics. So the codes that you develop and produce can be easily be shared for other people and make it available to GitHub for reproducibility. So we have some links for the EMSL JupyterHub docs and JupyterHub through Open OnDemand. So like I'll skip this part because Ivan has shown you how to launch a Jupyter notebook. I'll also show some demos towards the end on how to launch this and make this easy for the users to get a node and how to create notebooks for various model data integration tasks. So, so let's start with some use cases where I have used this Jupyter notebook and how it is helpful for EMSL users for model data integration. So we start with a GUI code called PFLOTRAN. So PFLOTRAN is a open source, a massively parallel code that can simulate flow, reactive transport, thermal transport, and energy balance. So which is very much needed for the data that EMSL users analyze. So it's a easy way to integrate your data into process models, physics-based process models, and develop simulations that can be used to understand the data that you're trying to collect and validate your models with. So a simple use case is like EMSL collects carbon degradation data. So you have various input decks and also advanced capabilities in PFLOTRAN for understanding carbon degradation models and other advanced carbon cycling models. So in this slide, what we're showing is a simple input deck to model reactions. So I'll be talking about that in the next set of slides. So you have easy set of cards to simulate various aspects of this reaction. Say, for instance, you have a simulation card. You have like, you can, once you collect the data, you have some concentration for the type of species you're collecting. So you have concentration decks, you have chemistry decks and various decks. In which you populate your values and you construct an input deck and run the PFLOTRAN code on that deck. So going into the model, as this is a model data integration talk, what is a process model for a simple for a simple carbon degradation look. So you have a simple A plus B reaction giving to C and D, where A is like an electron donor and B is like an electron acceptor. So this may be representative of microbially mediated carbon degradation models with biomass growth and decay over time. So to model the system, you have a system of ordinary differential equations with the following types of reaction rates. And in these models, you have a set of parameters that you need to calibrate with the observational data. So here for the simple reaction, we have like 7 different constants. So as the reaction get more and more complex, you have more and more reaction parameters that you need to calibrate. And you need complementary data to calibrate these reaction network parameters. So we'll show how to do this model data integration in the next set of slides. So once you created this input deck for a simple PFLOTRAN reaction model, so towards the end, we'll show how a demo to run this reaction model on Tahoma. And what I'm showing is a tip of an iceberg of various capabilities that exist in PFLOTRAN. So if you need help on PFLOTRAN or how to run PFLOTRAN on Tahoma, which is already available on Tahoma, so PFLOTRAN developers and users at PNNL are happy to help and assist. I'm primarily a user. I've been using PFLOTRAN for the past 8 years. So I can point you to various people who are the developers to help you on different tasks. I can also help you on how to use this code for your data that you're trying to collect and bring to the EMSL and use that on Tahoma. So it's a simple set of scripts. You load a set of modules. You create some paths for the PFLOTRAN executable, and you start running through this simple batch script. So that's what this set of lines do for running PFLOTRAN on Tahoma. So for more complex reactions, say for instance, you want to model carbon cycle for different set of decomposition models, or methane cycle, or different sets of complex reactions. We have a new capability in PFLOTRAN that is being developed over the past couple of years called Reaction Sandbox. That PFLOTRAN developers have provide the user community with. So you can script up your own reactions and run this through the Reaction Sandbox. So there are various other resources and links that are within this slide that will help you to get started with PFLOTRAN. And we at EMSL and also at PNNL are like very happy to help you to get the EMSL users to use PFLOTRAN Tahoma. And any questions related to PFLOTRAN installation, if you want to install it on your own laptop or the desktop before going to Tahoma, you can point out these questions. Or if you're running something on Tahoma and have some challenges to deal with, we have some user groups, and the user groups has a lot of previous messages which you can read and see what the previous users have encountered in using PFLOTRAN. So it's a very nice resource for people to understand the questions and also the type of challenges people encounter when using PFLOTRAN, and how other users help them to overcome these challenges. So so once you have this PFLOTRAN model, like for example, a reaction sandbox that provides EMSL users for implementing their own user reactions. You have EMSL data, for example, through Mooney or through other programs. You can construct reaction network models to combine this data and model in a iterative fashion, which is called AI-enabled ModEx. So the model experiment data integration. And what I'll be showing in the next set of slides is a set of ways to do that, and what might be the notebooks or Python scripts out there to help you out on this. So what does the AI-enabled ModEx workflow for the users contain? So it has 5 steps. So the step 1 is you find out or you code up a reaction sandbox or you can use an existing Python, like existing PFLOTRAN input deck that you feel relevant for a reaction network. And you have that process model. That's a step one in the right side figure. Once you have the process model, you generate some synthetic data based on the set of parameter ranges you have for various types of chemical species. So once you have that synthetic data, you train some AI/ML models, which can be a traditional model or even advanced models such as deep neural networks. And you also perform sensitivity analysis to find out which parameters are important and which parameters are not so important, so that you can calibrate the parameters which are important better. And once you have that information, then you couple with the experimental data. It can be either synthetic data or the MONE data or any other data that EMSL users are trying to gather. So for instance, to calibrate a reaction network parameters, you need time series data, at least a couple of points in time, how the concentration changes over time, or how the carbon degrades over time. So once you have that information, you calibrate it and run it in an iterative fashion so that you get a really predictive good model. So that's what is this AI-enabled ModEx workflow is about. And these are the 5 steps that I've described in previous way. We have notebooks available for each and every of the steps and associated Python scripts, shell scripts, and input decks for the users, starting with a simple microbial reaction, generating a big ensemble of PFLOTRAN simulations, sensitivity analysis through various methods. It can be local, global, or observation based, and both traditional and non-traditional ways to train AI/ML models using JupyterHub as a basis, or using Python scripts and shell scripts as another way to launch multiple set of models and compare with the experimental data. So like in the next set of slides, I'll show how you can use this in your own components. Say, for instance, we have developed this workflow. You want to use this for FTICRMS data. So you have another set of scripts wherein which we can use these components in this enable ModEx to perform sensitivity analysis for the FTICRMS data and see which parts of the data are important for upscaling. Other capabilities that are also available. Say, for instance, you want to use some other different models that you already have and want to do the model data integration for that. So you can use the Jupyter notebooks and the Python scripts that we have developed for your own individual use cases for the model data integration. So we have some advanced scripts for doing that. And also, if you want to use some deep learning methods such as deep neural networks or convolution neural networks for your own tasks, we have that scripts for different set of models. And one of the most important thing is hyperparameter tuning. So in an AI model, you want to vary various hyperparameters that are important for the predictive performance. You can use the HPC resource at Tahoma to run thousands of these models in parallel across the processors and train them at scale. So that's the other set of capabilities that I'll be showing you today. And we are also working on a set of scripts to analyze XCT data, SEM EDX data, and fuse them for better analysis and also for high dimensional model calibration. So with that, if you have any questions, you can contact me and I will start showing you some notebooks and see what you can do with them. So let me share my screen. So hope everyone can see my screen. Awesome. So so as Ivan pointed out, go to the Tahoma OnDemand and you have the cluster and Jupyter lab. So I launched this Jupyter Notebook lab and it allowed me to go to this this page wherein which I requested one node, primarily CPUs and 36 cores. So once you have that, I connected to this Jupyter Notebook it allowed me to launch this JupyterHub notebook. So every time when I test something on whether it's PFLOTRAN or your own model or do sensitivity analysis for different ones, I have some sanity checks and some test cases. So if a new user comes in and wants to play with the codes that EMSL has developed, we have some set of basic notebooks, advanced notebooks, and testing various Python software, so that when you run these notebooks on the HPC resource, you get better accustomed to this by running these test scripts. So we also have test PFLOTRAN scripts, and to get the user used to the PFLOTRAN notebooks. So the notebook contains the folder contains various notebooks here, in which, for example, the data worth analysis provides a way to assess how valuable is your data compared to the experimental stuff. So we have, for instance, various types of information and methodologies to do this data worth analysis. So we load the data, we create the paths, we see what are the various metrics that we assess. And once we have that metrics in place, we store that metrics and do some simple analysis to see where you can use this information. So, and also you can create some plots. Say, for instance, you want to plot some information related to the time series data or the type of simulation data that you get. We have some Python notebooks for that. Say, for instance, you want to plot the concentration of the chemical species over time, you have that information. So you also have information for pre-processing data for different chemical species, feature importance using different methodologies, and training and validation, training, validation, testing data. So that's the basic notebooks. So for the advanced notebooks, say if you are interested in bringing your own model, we have deep neural architectures and convolution neural architectures. Say, for instance, you want to play with Python scripts, we have that Python scripts here. And you want to do some advanced hyperparameter tuning, say, for instance, for a convolution neural network, we have a set of scripts that you can use and iterate with minimal training curve to develop hyperparameter tuning, perform that analysis, and develop AI models. So for instance, like I'll show on the shell part how to do this. Say, for example, so here I have a test PFLOTRAN. So whenever a new user comes, I give him this folder so that he gets used to how to run this on a Tahoma system. So we have a batch script. So wherein which what Ivan has pointed out, we have a tailor-made set of batch commands. You load the modules, you run the associated PFLOTRAN script. So it's very simple. It doesn't take much time to run that. So so if you run this script, it submitted a job, and you can see how the job progresses. And also it started to run, and you can see what type of information that it produces out. Say, for instance, yep, it's done. So let's see how it is being. And you can see the outputs that it produces through this notebook. So this is simple sanity check to make sure your PFLOTRAN runs. For more complex models, so it takes quite some time. So you can run this on multiple cores. Say, for instance, so this is like this is a 10 million mesh cell on a watershed scale to understand hydrobiogeochemistry and physics on that. So we have like 4 nodes, 144 cores run over a span of 24 hours. You can run much smaller models to more complex models in Tahoma. It's easy and straightforward to do that. So and also, like if you want to do some AI ML training or like hundreds and thousands of nodes, it's also easy. So we have a test scripts that allow you to do that. So for instance, this test script, with this, you can run 100 nodes, you can run TensorFlow to train TensorFlow models in parallel, perform hyperparameter tuning. So the shell scripts remain the same. You create a SBatch and load the module, source it, and run the models in parallel. So if you have, the main thing is if you have any questions, there's a lot of information to digest. So if you have any questions related to modeling or model data integration or how to play with it with your own set of tools, we have, you can reach out to me. I can point out to the people who work in EMSL and also PFLOTRAN developers at PNNL who can help you out on various other tasks. So maybe with that, I will stop sharing my screen and we are here to answer questions.
Thank you, Maruti. All right, we do have some questions, and I would also invite the rest of our attendees, if you have questions that you've been hanging on to go ahead and put those in the chat so that we can get all of our questions addressed. The first question is from Doug Baxter for Evan. And Evan, if you want to turn your camera back on, that would be great. So Doug's question is, he's asking whether or not if you have to be a privileged, or if you're a privileged user, can you see all jobs?
I feel like Doug just asked me to check my privilege.
Oh.
But Doug, as far as Slurm's concerned, I'm not a privileged user. So yes, you can see all the jobs as a non-privileged user, as far as I know. So
But what about, I think he's saying a privileged user. He's saying can only a privileged user see all jobs?
I'm saying all users can see all the jobs.
Okay, got it. Okay, great. And then Arson, I am hoping I'm pronouncing that correctly. Apologies if not. Also, question for Evan. Can we request for more node hours if there's nothing left? Yes,
and you reach out to Satish for that. Obviously, you can send an email to MSc Consulting at emsl.pnnl.gov, the link in the slides, and Satish will see those as well. But yeah, you can request those as well.
Okay, great. Maruti, a question for you. How can a person learn FLOTRAN, and are there any short course materials that could be helpful?
Sure. I think there's this if you go to the pflotran.org, maybe if it's I think I'll put the link here. I forgot to show that. So if you go to the pflotran.org, there is this Bitbucket site available, and in that you have a set of slides and inputs for a short course. So I'll put that in the link. People can go through that. This is an exhaustive list of problems and use cases that people can go through and understand that.
Great, thank you. I see that you put that. I do see a link in the chat that we can share with folks. Another question for Evan, and this is from Margaret Chung. So we can upload data to Nexus, the EMSL user portal. How about downloading data from Nexus to Tahoma?
I don't have a way to do that through Open OnDemand, but I do have a set of scripts that can do that. We do that all the time over on the Boreal cluster. And if you send me an email, I will tell you where that script is.
Okay, so, great. Okay. So maybe you can refresh your memory a little bit. How does a person get access to Tahoma, Evan?
There is a link in the slides. I don't have up right now, but
okay.
You go to you go to the Nexus portal and request access to the resource.
Okay.
There's a request page to do that.
And
then you get an approval and you request time on it. So through through the normal EMSL request process.
Okay, and just to be clear, do you mean also that they would need to submit essentially like a letter of intent to an open proposal call to be able to access it? Okay.
Probably. There's multiple different ways they can request, right? And Satish, if Satish was on here, we could pull him in as a panelist and he could tell you a lot more about that. I don't get as involved in that as maybe people are. That's why I had a link to how to do it.
Okay. And this is probably a good opportunity to plug. We do have an open call for research proposals. The exploratory research call for proposals is open for letters of intent until July 6th at 5 p.m. So if you are interested in using Tahoma and these resources, that is an opportunity for you, and we will share the link for that as well.
Yeah.
So another question for you, Maruti. How do I use these AI capabilities for different codes and data analysis? And do you have any examples?
Mm-hmm. So when a new user comes to EMSL, and if he is interested in using these model data integration tasks, so we have a set of notebooks that he can get started with. So he understands how to run them. And once he gets an understanding of that, he can bring his own model for model data integration and use various parts of the notebooks for his or her analysis. So the notebooks that I've shown here are for PFLOTRAN and for other set of watershed data that we have done previously. So he can use various set of these notebooks to integrate with this or with his or her tasks to make it much more accessible. So if they have any questions, they can reach out to me or through MSc Consulting so that we can provide support for them.
Thank you. Another question from our audience, Tian's Zong is asking, this is probably a question for you, Evan. Does Tahoma support Globus data transfer?
Yes, it does.
Okay.
I will post a link. You search for the PNNL EMSL MSc data transfer node. And you log in with your username and secure ID. And there's a Tahoma file system there. And you can transfer directly into the Tahoma file system. We support that. Send an email to MSc Consulting, but I can post a link to that directly here in a moment when I grab the link for him.
Okay, great. Okay. Before you do that, one more question. How do I get more web-based applications added to Open OnDemand?
The best way is to send a link to MSc Consulting and probably CC me directly so I know it's coming.
Okay, I see a theme here.
Yeah.
Okay, Maruti, if I need help on PFLOTRAN or AI-enabled ModEx for sensitivity analysis, who should I reach out to?
I think the best way is like the PFLOTRAN user groups that I think Genoa, you have put in the chat. That's the best way to reach out. You can reach out to the MSc Consulting. We can provide the notebooks for sensitivity analysis, and and also the slides have the link for a GitHub in which we have put sensitivity analysis for FDICRMS and various other model data integration tasks. And if nothing works out for you all, just email me. So I believe you have my email. You can email me and I'll be happy to help you all to get this started.
Thank you. All right, I see one more question that I'm going to put out a last call in the chat. If you have any additional questions, this is your last chance to ask them in this format, or you can follow up with our speakers via email. So, Evan, this is for you. Can a user develop their own applications for Open OnDemand?
Yes, they can. So we haven't enabled that for everyone, but if someone wants to, I can easily enable it if they want me to. And we have decided to open that for everyone. We just haven't done that yet. And we're trying to upgrade to the new version. And when we do that, hopefully in the next couple of months, everyone will be able to do that. We just haven't got to that step yet. So, and mostly that involves you create the right directory in your home directory and suddenly a develop menu appears. You guys might have seen my develop menu as we were going through things, but once you make the right directory, you can just start making your own apps because they're all running as you. There's no real danger of you breaking the system other than your own system. So
it's not a difficult process, it sounds like.
Not really. You can just get started and make your own apps. So
Cool. Very good. Okay.
And there's lots of documentation examples out on the internet how to do that. So it's
great. Okay. Well, great. I'm not seeing any additional questions. So that is going to wrap it up for us today. Thank you, Maruti and Evan, for sharing about available capabilities. And again, one last plug for that exploratory call. You can get information on the EMSL website about how to submit a letter of intent. And we hope to see you July 24th to the 28th at EMSL Summer School. And we will be talking about data analysis and visualization for omics. So please join us and we'll see you soon. Have a great day. Thanks so much.